Hi, Virtual Chemistry. We're going to go through some of our nuclear decay reactions that you are supposed to do for your homework this week. So if you pull this document up on Canvas, if you are able to print it off at home, it would be really handy if you could just print it off. You could write right on top of it, and then you could take photos of it to submit to me via Canvas for your homework assignment. But your alpha, your beta, and your gamma are all summarized up here at the top of the worksheet. So we are going to go through a couple of these together. We're going to start with the word equations, which, bear with me for a second, are all down here on the lower portion. If you cannot print this document off at home, feel free to do your homework on a piece of notebook paper and just write these equations out. Okay? So the cool thing about nuclear decays is that all we have to do is equalize the numbers, the mass number, which is the very top number. So when you look at number 1, I have an atomic mass in the parent molecule of 129. That 129 means it's the protons and the neutrons added together. The number on the bottom, the 53, that is my protons. Okay, so if iodine goes through a beta decay, which that's your beta particle, your 0, -1 electron, we're going to figure out what the daughter molecule would be. So we started with 53. So when you come over here to do the bottom number, you say -1 plus what gives me 53. I hope you're saying 54 because that's correct. So you write your 54 in there in the bottom. Okay? At the top, if we started with 129, over here we had a mass number of 0 change, so we just fill in the 129 over 54. 54 is, on your periodic table, here was our iodine, 53. 54 is xenon. Okay, the cool thing about a beta decay is the daughter will be 1 to the right on the periodic table of the parent. That's what happened right there. So I have a bunch of stuff written on my board here for our nuclear decays. There's my alpha decay summarized. It says if I did an alpha decay, I will move 2 spots to the left. That means wherever my parent molecule was, I would move 2 spots to the left if it's giving off an alpha decay. I'll show you this one I have written up here on the board. Here I have an alpha decay of potassium 40. It has a mass number of 40. It gives off its alpha particle, which is right there, the helium nucleus. So I go 40 minus 4 gives me my mass number of 36. 19 minus those 2 gave me a mass number of 17. So my new element it forms, my new daughter, is chlorine. Chlorine 36. So again, we'll kind of look at this periodic table. But if my parent molecule was potassium, I just moved backwards on the periodic table 2 spots, which took me 1 to argon, 2 to the chlorine. So we can kind of use our periodic table as a game board. Alpha, move 2 spots to the left. Beta decays, you move over 1 spot to the right. Gamma, there's no moving because you have no math to do in a gamma decay, which is really awesome. Okay, so I have a couple of these mapped out on the board for you. So we're going to read them kind of carefully. Okay, number 12, excuse me. Number 12 says, when protactinium 229 goes through 2 alpha decays, francium 221 is formed. So we just have to read them really carefully, the word equations. Protactinium, Pa, is my radioactive isotope that's experiencing the decay. I draw the arrow because each parent is going to get an arrow in decay. You'll get your radioactive particle, which were the 2 alphas. I like to write it with a big coefficient of 2 in front of the alpha particle. It then becomes a multiplier. 2 times 4 would be a change of 8 for the mass. 2 times 2 is a change of 4 for the atomic number. So we made our francium 221. It gave us all of that info in the word problem. I just had to look up francium's atomic number, which is 87, or I did my math here. 91 minus 4 is 87. You can write your 2 alpha decays like you see written there, if you would prefer. Let's look at number 17 together. I have it already mapped out for you. What atom produces scandium-47? Scandium-47 is the daughter that we're starting with. So read it carefully. What atom, I've already done the math for you, but produces scandium-47 when it goes through a beta decay? So you really should start by writing the scandium-47 and the beta particle. Then you'll work your way backwards with the math. 47 plus 0 gives me a mass of 47. 21 plus negative 1 gave me an atomic number of 20. Number 20 is calcium. Okay? And lastly, we'll do number 18 together. What new element is formed when curium-244, so that's my starting point, emits 2 alpha particles and 3 gamma rays? There's my 2 alphas, there's my 3 gammas. Okay, when I do all of my math, 244 is what I have to end up with for my mass number. So 244 minus 8 is 236. We have to do nothing with the gammas because 3 times 0, it's 0. 96 is what we started with for atomic number. 96 minus 4 is a 92. That's uranium. Okay, so there's a really quick lesson on how to do your homeworks. Okay, all of these ones up top are really quite easy. Just justify the mass numbers on the left side of the arrow versus the right side of the arrow and fill in all those question marks. Okay, good luck. Submit it on Canvas when you are done. Thanks, guys.